Hey everybody, these notes are meant to accompany the second homework assignment, and you should watch this video before class on Monday, September 30th. Here we go. So first we're going to start with solving quadratic equations, and there are many ways to do this. One method, my preferred method, is typically to factor. To factor, you first have to have everything on one side of the equation. So we're going to multiply off the left-hand side. X times x is x squared. X times 3 is 3x. Negative 5 times x is minus 5x. Negative 5 times 3 is minus 15. And we're going to subtract 20 from both sides. Say that. We're going to combine like terms. X squared. 3x minus 5x is minus 2x. Negative 15 times, negative 15 minus 20 is minus 35 or negative 35. Still equal to 0. And then we're going to factor. So one way of factoring that works nicely when you have a 1 as your coefficient of x squared is you look for numbers that multiply to negative 35 and add up to the coefficient of x, which is negative 2. So people draw this diamond thing. I've never really been a fan of that, but if you like that, cool. I don't find it helpful. So I'm looking for numbers that multiply to negative 35 and add to negative 2. Well, the only correct answer here, and there's only ever one correct answer, if there's one at all, is negative 7 and positive 5. So I'm going to write this as x squared. Well, I've done this kind of the long way, but fine. This is actually a way, this is the way I'm about to do this is kind of the more complicated way. It's fine. I'm writing negative 2x as minus 7x plus 5x minus 35 equal to 0. So I haven't changed anything because negative 7x plus 5x is still negative 2x, or adds up to negative 2x. And then we're going to factor by grouping. From x squared minus 7x, we're going to factor out an x, and we're left with x minus 7. From 5x minus 35, we're going to factor out a 5, and we're left with x minus 7. To do it this way, the same thing has to be left over. And then we're going to factor out an x minus 7 from each term and get x minus 7 times x plus 5, right? Because there's an x left here and a 5 left here, equal to 0. The shorter way to do this would have just to have said x minus 7 times x plus 5, because you're looking for numbers that multiply to negative 35 and add to negative 2. But this is kind of the longer way that works when you have a more complicated leading coefficient. Finally, we set each factor equal to 0. So if x minus 7 equals 0, we get x equal to 7. And if x plus 5 equals 0, we subtract 5 from both sides and get x equal to negative 5. Cool. Same kind of deal for the next one. Except before we can solve it, we have to bring everything to one side. I prefer to bring things to the side where the coefficient of the highest power is positive. So here I have a 1x squared, so I'm going to leave that on the left. I'm going to subtract 21 from both sides to get that. Same deal, I'm looking for numbers that multiply to negative 21 up to 4. Those numbers are positive 7 and negative 3. So I'm going to factor this as x plus 7 times x minus 3, still equal to 0. And then I'm going to set each factor equal to 0. Often people kind of skip this step and say, well, if x plus 7 equals 0, then x equals negative 7. But you can write it all out. X plus 7 equals 0. X equals negative 7. X minus 3 equals 0. X equals 3. The reason this works is because if you set this factor equal to 0, 0 times anything is still 0. It doesn't work if it's equal to any other number. So that's what we had to, like if you said x plus 4 is equal to 21 and then tried to find numbers that multiply to 21, there's lots of options. There's only one option or one way that things multiply to 0. 0 times something. Same deal here. In fact, I would encourage you to try this one on your own before you watch me do it. So I'm going to bring everything to the left-hand side, and I do like to write things in order of highest power to lowest. So x squared minus 5x to the first plus 6 equals 0. I'm writing in decreasing powers of x. Looking for numbers that multiply to positive 6 and add up to negative 5. Those numbers would be negative 2 and negative 3. So I'm going to get x minus 2 times x minus 3. And yeah, notably, right, negative 2 times negative 3 is positive 6. Negative 2 plus negative 3 is negative 5. I can also do this the other way if you like. You could have said, I'm looking for those numbers. Right? So the numbers are, right, if you do the little diamond thing, which again, I'm not a huge fan of, but fine. I don't really know how you decide what goes where. You put the 6 here, the negative 5 here, and I want numbers that add to that and multiply to that. Cool. And then you could, instead of writing it like this automatically, you could say, well, x squared minus 5x plus 6 equal to 0. You should write the equal to 0 every time. Becomes x squared minus 2x minus 3x plus 6 equal to 0. And then we factor by grouping. Factor out an x, you're left with x minus 2. Factor out a negative 3, and you're left with positive x minus 2. Factor out an x minus 2, and you've got x minus 2 times x minus 3. Oh, look, it's the same. So either way you do, it's fine. And then we're going to set each factor equal to 0. This is going to give me x equal to positive 2. This is going to give me x equal to positive 3. And those are my solutions to this equation. Let's keep it going. There's quite a few examples to get through. I know it's kind of a lot. But this is all just be algebra review. So this one is more complicated. I might not even factor it. I might just jump straight to the quadratic formula in other examples. Here I am going to factor it because it is factorable. So here's how you factor something where the coefficient, the leading coefficient is not 1 or negative 1. You say, well, a times c, and again, we're thinking of ax squared plus bx plus c. So the a is 6, and the c is negative 3. That's equal to negative 18. So you're looking for numbers that multiply to a times c. In all the previous examples, a times c was just c because our a's were 1, right? Here, the a times c was 1 times negative 35. So looking for numbers that multiplied to a times c was just looking for numbers that multiplied to c. Here it's a little different. So looking for numbers that multiply to negative 18 and add up to still negative 7. I think the numbers that fit the bill are negative 9 and positive 2. Yep, those work. So then we actually have to do it kind of the longer, complicated way. We can't just say it's x plus 2 times x minus 9 because the x times x doesn't multiply to 6x squared. Instead, we're going to write it as 6x squared. And it doesn't even matter if you do minus 9x first or plus 2x first. If I have a minus and a plus, I like to do the minus one first. It makes it a little easier, I think. So I'm going to do it as minus 9x plus 2x minus 3 equal to 0. From the first two terms, I'm going to factor out the greatest common factor. I have a 3x I can factor out from each term. Factor out a 3x, I'm left with a 2x minus 3. That happens to be the same thing here. So what I'm really going to do here is kind of do this weird. I'm going to write it as 1 times 2x minus 3. Then from each of these terms, I factor out the common factor of 2x minus 3. I'm left with a 3x plus 1. And then I set each factor equal to 0. And this is definitely a time when setting each factor equal to 0 is good so we can show our work. So I set 2x minus 3 equal to 0. I get 2x equal to positive 3. I get x equal to positive 3 halves. If I set 3x plus 1 equal to 0, I get 3x equal to negative 1. I get x equal to negative 1/3. I will also mention here that you could have gone the other way, right? If you instead decided to go, where's my blue pen here? Sorry. This one works. If I instead decided to go 6x squared plus 2x minus 9x minus 3 equal to 0, I can still factor by grouping. Factor out a common factor of 2x here. I'm left with a 3x plus 1. Here I factor out a common factor. Instead of a 3, I'm going to pick negative 3. You almost always want to pull out the negative if there's a negative first here. Minus 3 times, I'm left with a 3x plus 1. And then I factor out the 3x plus 1, and I'm left with a 2x minus 3. And look, the factoring is the same. 2x minus 3 times 3x plus 1 is the same as 3x plus 1 times 2x minus 3. So either way you order those things, it'll work out just fine. Same idea here. I'm going to rewrite this first, of course, as everything equal to 0. So 4x squared minus 11x plus 6 equals 0. My a times c is 4 times 6, which is 24. So I'm looking for numbers that multiply to 24 and add up to negative 11. I believe those numbers are not 8 and 3, but negative 8 and negative 3. So I'm going to write this as 4x squared minus 3x minus 8x plus 6 equal to 0. So from the 4x squared minus 3x, I'm going to factor out just an x. I'm left with 4x minus 3. Here, I could factor out a 2, but if I factor out a 2, I'd be left with a negative 4x plus 3, and I want to be left with a positive 4x minus 3, so I'm going to factor out a minus 2, so I have a positive 4x minus 3. Because these two things, the leftovers, really have to match each other to continue. So then I have a 4x minus 3 factored out. I'm left with an x minus 2. I set each factor equal to 0. So setting x minus 2 equal to 0, I get x equal to 2. Yay. Setting 4x minus 3 equal to 0, I get 4x equal to 3. I get x equal to 3 divided by 4. Those are my two solutions. Nice. So I would encourage you all to try this one for yourself. This one actually, I will point out, this one is a little tricky. I'm not going to lie. The numbers are kind of big, but try it on your own, give it a shot, and then watch me do this. So same deal. I have a times c equal 12 times 6, which is 72. So I'm looking for numbers that multiply to 72, and there are a lot of options for multiplying to 72 and add to 17. So just to list them out, I have 1 times 72, 2 times 36, 3 times 24, 4 times something, half of 36, 18, 6 times 12, which is how we got there, 8 times 9. And I think that's all the ways you can multiply to 72 using positive numbers. But if we add them up, 1 plus 72 is too big, 2 plus 36 is too big. Right, we want to add up to 17. So 6 plus 12 is 18, 8 plus 9 is 17. So we want the 8 and the 9. So we're going to rewrite this as 12x squared plus 8x plus 9x plus 6 equal to 0. If you did 12x squared plus 9x plus 8x plus 6 equal to 0, that would also work. Factor out the greatest common factor. That's a 4x here. If I pull out or divide out the 4x, I'm left with a 3x plus 2. Same deal here. I'm going to factor out a 3. I'm left with a 3x plus 2. And we are happy because the remaining factors, the remaining things after we factor out are both the same. So we factor out the 3x plus 2 from both of those larger terms. And then from the first term, we're left with a 4x. From the second term, we're left with a 3. We set each factor equal to 0. 3x plus 2 equal to 0 yields 3x equal to negative 2, which gives us x equal to negative 2/3. And I shouldn't use an equal sign. I should use an arrow there. And then similarly, 4x plus 3 is going to give us, 4x plus 3 equal to 0 is going to give us 4x equal to negative 3 is going to give us x equal to negative 3/4. Nice. So factoring is great if it factors, but not everything factors. Well, and sometimes factoring isn't great. Like this one, factoring, it might have been really hard to do. It might have been easier, although it probably wouldn't have been easier to use the quadratic formula. Before we get there, though, let's talk about a couple other examples like this one. So this one here, you could do the way we've been doing it. You could say, yeah, it's kind of a pain. If we multiply this out, you're going to get 3x plus 2 times 3x plus 2 equal to 25. That's going to be 9x squared plus 6x plus 6x plus 4 equal to 25. So 9x squared plus 12x minus 21 equal to 0. I think you can divide the whole thing by 3 if you wanted to, and say 3x squared plus 4x minus 7 equals 0. Does this even factor? I think it does. You're looking for numbers that multiply to a times c, so negative 21, and add up to positive 4. And those numbers are 7 and negative 3. So we're going to write this as 3x squared, blah, plus 7x. I didn't follow my own advice. I should have put the negative 1 first. Oh, well, let's change it. Let's do 3x squared minus 3x plus 7x minus 7 equal to 0. Factor out. I want to save myself some room here because I'm going to do it a better way in a second. From here, factor out a 3x, you're left with x minus 1. From here, factor out a 7, you're left with x minus 1. So then we can factor out the x minus 1 and get x minus 1 times 3x plus 7 equal to 0. This is going to lead us to x equal to 1. This is going to lead us to x equal to negative 7 divided by 3. Okay, well, let's see a better way, because there is a better way. So if you specifically already have something squared equal to a number, just a number, it can't be like an x over there, you can just take the square root of both sides, but you have to remember to slap on a plus or minus, because what we're really doing, I know we talked about this in class a little bit, is you're saying the square root of 3x plus 2 squared equals the square root of 25. I know we talked about last time how if you take the square root of something squared, you actually get the absolute value of that something. So what you're really saying is the absolute value of 3x plus 2 equals the square root of 25, which is 5. But that means that 3x plus 2 could either equal positive 5 or negative 5, because the absolute value of 5 is 5 and the absolute value of negative 5 is 5. So usually we skip all this though, and we just say, oh, if you're taking the square root of both sides, you're going to get straight down to that right there. The square root of 3x plus 2 squared is 3x plus 2, and you do a plus or minus square root of 25, which is plus or minus 5. And then 3x is equal to plus or minus 5 minus 2, and then x is equal to plus or minus 5 minus 2 divided by 3. So one answer is positive 5 minus 2 over 3, which is 3 over 3, which is 1. And the other answer is negative 5 minus 2 over 3, which is negative 7 over 3. Exactly like those answers there. To me, this felt like a lot less work. Let's look at the second example. So you don't have to have a nice square number on this side for the square root property to work. It feels better if you do, but it's not required at all. So square rooting both sides here, we get 2x minus 1 equal to plus or minus the square root of 7. Add 1 to both sides. So you get 2x equal 1 plus or minus the square root of 7. Divide both sides by 2. So 1 plus or minus the square root of 7 all over 2. You can write it like this, or if you feel the need to write it as two different answers, you can say you get x equal to 1 plus radical 7 over 2, and x equal to 1 minus radical 7 over 2. But this is a perfectly fine and probably preferable way of doing it. Oh, so I had notes about how you do that. I think so I would try this one on your own. So we could do this the long way, but we don't really need the long way because we already did one like that. If you're going to solve this, you get x minus 3 equal to plus or minus 4. So x would equal to positive 3 plus or minus 4. So x would equal 3 plus 4 or 3 minus 4. Which you can check if you plug back in, right? 7 minus 3 is 4, 4 squared is 16. Negative 1 minus 3 is negative 4, negative 4 squared is 16. Or you could do it the long way by doing x squared minus 6x plus 9 equal to 16. X squared minus 6x, 9 minus 16 is negative 7. You could factor that as x minus 7 times x plus 1. And oh yeah, that's going to exactly lead to those solutions. So there's lots of different ways to solve a quadratic equation, depending on how it looks in the beginning. Sorry, my back's a little sore. I've been sitting too long today. You also have the option of using the quadratic formula. So we're trying to solve a quadratic equation, which typically looks like something times x squared plus something times x plus a constant equal to 0, where the coefficient of x shouldn't be 0. Sorry, the coefficient of x squared shouldn't be 0. Otherwise, it's not a quadratic equation. It's a linear equation. The solution is that x is equal to two different things. It's negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Note that b squared minus 4ac is called the discriminant. It's not super important to know that, but it occurred to me that I should say it. So the inside of the square root part there is called the discriminant of your solution. So let's solve these equations by using the quadratic formula. So I'm just going to point out here that for this equation, for this equation, x squared plus 2x minus 5 equals 0, a is equal to 1, b is equal to 2, and c is equal to negative 5. So I'm just going to really throw all those things into this formula. So my solution is going to be x is equal to negative 2 plus or minus the square root of 2 squared minus 4 times 1 times negative 5. All of that divided by 2 times a. Which, if a is 1, I would probably just write 2 instead of 2 times 1, but good to see it there. So then we should simplify this as much as possible. It's going to be negative 2 plus or minus the square root of 4 minus 4. So I should say minus 4 times 1 times minus 5 is positive 20. So we have 4 plus 20 all over 2. The 2 divided by 2, well, the negative 2 divided by 2 is negative 1, but we can't do the division yet because each part in the numerator has to get divided by 2. So if you wanted to, you could break it up as negative 2 divided by 2 plus or minus the square root of 24 divided by 2. I usually don't like to do that, but it's totally fine. But make sure that each part in the numerator is getting divided by the 2. 2 divided by 2 is 1, so you get negative 1 plus or minus. We can simplify this square root of 24 as the square root of 4 times 6, still all divided by 2. And then the square root of 4 is equal to 2. So this is really 2 root 6 divided by 2. 2 divided by 2 is 1. So we end up just getting negative 1 plus or minus 1 times root 6, or just negative 1 plus or minus root 6, because 1 times root 6 is just root 6. So that's how we would typically do a problem like this. I will point out the problem number 5 that we did just a little bit ago, which was solving 4x squared minus 11x plus 6 equal to 0. Maybe we didn't want to try to factor that. Because I'll point out, like this one here, if we tried to factor it, it wouldn't have worked. If you look for numbers that multiply to -5 and add to 2, you aren't going to find them. Here it would work, but maybe it's just like it feels like a pain. So instead, what we can do, and I don't think we actually, I'm trying to remember now, did we do that one that way? Number 5? No, we did. Yeah, we did factor that one. Yeah, it wasn't too bad, I guess. But instead of doing it that way, let's try using the quadratic formula. So here our A is 4, our B is -11, and our C is +6. So throwing everything into the formula, we get -11 plus or minus the square root of -11 squared minus 4 times A times C, so 4 times 4 times 6, all over 2 times 4. Let's simplify this a bit. That's the only kind of downside of the quadratic formula is that it always works, but you often are required to simplify your result. -11 squared is 121. It is positive. 4 times 4 times 6 is not my favorite, but let's see. 4 times 6 is 24, and 24 times 4, I don't know, but 24 times 2 is 48, and 48 times 2 is 96. All divided by 8. So then 121 minus 96 is going to be exactly 25. So you have 11 plus or minus the square root of 25, all divided by 8. Square root of 25 is 5, so you get 11 plus or minus 5, all over 8. 11 plus 5 is 16. 16 divided by 8 is 2. 11 minus 5 is 6. 6 divided by 8 is 6 divided by 8. But we could then simplify that as 2 and 3/4 are our two solutions. Which if we look back at problem 5 from a minute ago, we can see that, oh yeah, those are the same as the solutions we got. X equals 2 and x equals 3/4. So either way you want to solve it, totally fine. You can factor if it's factorable. If it's not factorable or it seems like factoring is going to be terrible, you can use the quadratic formula. Let's do the same thing here. So I'm going to solve this by using the quadratic formula. Again, I think it's always worthwhile to write down what A, B, and C are. A is the coefficient of x squared, B is the coefficient of x, C is the constant term. So my solution here is going to be that x is equal to -6. I would normally just write 6. Plus or minus the square root of, I would probably kind of simplify things as I go. So instead of saying -6 squared, I'm just going to write +36 minus 4 times A times C. I do kind of usually like to write that part out, all over 2 times 2. So that's going to be +6 plus or minus the square root of 36 minus, let's see, 4 times 2 is 8. 8 times 7 is 56, all over 4. Which is equal to 6 plus or minus the square root of 36 minus 56 is -20, and we have a problem because the square root of a negative number is not real. And so when you're solving something like this in this class, we typically, unless specifically asked for, we typically say that there aren't any real solutions if we end up with the square root of a negative. So there are no real solutions. Occasionally, you might be asked to find imaginary/complex solutions, but that is not what we're doing right now. So once you get to a square root of negative, or if you have a discriminant that is negative, right here our discriminant's negative, there are no real solutions. Let's look at the next one. This seems like another time to use the quadratic formula. So once again, our A is 1, our B is -6, our C is +2. Oh, I know why I did this one. There's another way to solve this we'll talk about in a second. But one way to solve this would be using the quadratic formula. And it's going to be x equal to -6 plus or minus the square root of -6 squared minus 4 times 1 times 2. Probably don't need to write 4 times 1 times 2. You probably just write 8. All over 2 times 1. That's going to be 6 plus or minus the square root of 36 minus 8, which is 28, all divided by 2. Again, 6 divided by 2 is 3, but we can't just cancel the 2's because we have to make sure that the radical also gets divided by 2. So I would probably simplify this as 6 plus or minus the square root of 4 times 7, all over 2, which is then 6 plus or minus 2 root 7, all over 2. And then you can divide each term by 2 and get 3 plus or minus 1 times root 7, or just 3 plus or minus root 7. That's a perfectly fine way of doing it. Occasionally, people find it useful to use a process called completing the square. It's only really useful if you have a 1x squared and an even number times x. If you have other things going on, completing the square usually isn't worth the effort. But I'll show you one example here because I do think it's occasionally worthwhile, and we sometimes do it when we talk about circles. So the first step, if you're going to complete the square, is to just get the x squared and the coefficient of x term on the same side and everything else on the other side. So I'm going to write this as x squared minus 6x equal to -2, subtracting 2 from both sides. And then the way we complete the square is we take the coefficient of x, which is -6, we divide that by 2, which is -3, and we square it, which is +9, and we add that to both sides. So we're going to have x squared minus 6x plus 9 equal to -2 plus 9. We didn't change anything. We just added 9 to both sides. The equation is still the same equation. But the point of doing that is that now the left side is some quantity squared. We can rewrite this as x minus 3 quantity squared, because it's x minus 3 times x minus 3, which is x squared minus 3x plus 9, which is exactly that, equal to -2 plus 9, which is 7. And then we can use the square root property from a couple of examples ago to say, oh, that means x minus 3 is equal to plus or minus the square root of 7. And that means x is equal to 3 plus or minus the square root of 7. It's a totally fine way of doing it, but again, it's only really good if you have a 1 as your leading coefficient for x squared and an even coefficient for x. It's kind of gross if you have an odd coefficient for x. Okay. I think that's all there is for the quadratic formula. Oh, no, there's a little bit more. So sometimes we have things that kind of look quadratic, but are not actually quadratic. And there's a couple ways to deal with them. One way to deal with them is just to say, well, I can see that instead of having like x squared minus 13x plus 36 equal to 0, I have x to the fourth minus 13x squared plus 36 equal to 0. I'm still looking for numbers that multiply to 36 and add up to -13. Those numbers are -4 and -9. So this is going to factor as something minus 9 times something minus 4 equal to 0. But instead of having an x here and an x here like we have before, it's going to be an x squared here and an x squared here. X squared times x squared is x to the fourth. Minus 9x squared minus 4x squared gives me a minus 13x squared. And -9 times -4 is positive 36. There is another way of doing that, which we'll do in the second one here, but that's one way to go about it, which works perfectly fine. And then we could actually factor this one further, or we could just set each part equal to 0. I kind of like saying each part equal to 0 when you get to this stage. So I would probably say we have x squared minus 9 equal to 0. We have x squared equal to 9. We have x equal to plus or minus 3. Here we have x squared minus 4 equal to 0, x squared equal to 4, x equals plus or minus the square root of 4, which is plus or minus 2. So those are my 4 solutions to this equation, plus or minus 3 and plus or minus 2. I will just point out here, if you like, you could have factored this more. X squared minus 9 just factor as x minus 3 times x plus 3. X squared minus 4 factors as x minus 2 times x plus 2. And then you could have set each factor equal to 0 and gotten your 4 solutions that way. Same idea here, except, well, first we need to rewrite it as x to the 6th plus 3x cubed minus 40 equal to 0. And what some people like to do, instead of just seeing that like x to the 6th is x to the third times x to the third, they say, well, I'm going to do what's called a u substitution, where I'm going to let u equal x to the power that is closer to 0. So I'm going to let u equal x to the third. And then I'll point out that u squared is x cubed squared, which is x to the 6th. So I'm actually going to replace this equation with the variable u. So instead of x to the 6th, I'm going to write u squared. Instead of 3x cubed, I'm going to write 3u minus 40 equals 0. And I'm going to factor this like I normally would. I'm looking for numbers that multiply to -40, add up to positive 3. I believe those numbers are positive 8 and -5. So I have u squared. Sorry, I keep doing this the long way. I want to do it the short way. I have u plus 8 times u minus 5 equal to 0. And then you can kind of go one of two ways. You can either kind of do it like here and replace u with x cubed and say x cubed plus 8 times x cubed minus 5 equal to 0. Or you can just solve each thing and say, well, u plus 8 equals 0. U minus 5 equals 0. In this case, you get u equals -8, u equals positive 5. But then you have to replace u with what it's equal to. So then we have x cubed equal to -8 and x cubed equal to +5. X is the cube root of -8, which is -2. X is the cube root of 5, which is just the cube root of 5. Or if we'd solved it this way, same idea. You get x cubed plus 8 equal to 0, x cubed equals -8, x equals -2. Here you get x cubed minus 5 equal to 0, x cubed equal to 5, x equal to the cube root of 5. It doesn't really matter when you plug back in what u is equal to in terms of x. You just have to do it at some point. So you can kind of go either way. You also could have just factored this as straight from that to that by saying, oh yeah, I know that x cubed times x cubed is going to be x to the 6th. I'm going to get 8x cubed and then minus 5x cubed to give me a 3x cubed. Either way. Those don't come up too often, but they do come up occasionally. So if you see something that kind of has a quadratic look to it, meaning it's x to a power plus or minus something times x to half that power, right? 2 is half of 4, 3 is half of 6, plus a constant, that's a good sign it's a quadratic form. Same deal here, right? We have x to a power, x to half that power, plus a constant equal to 0. So I'm going to do it the other way. I'm looking for numbers that multiply to -15 and add to +2. Those are going to be 5 and -3. So I'm going to have x to the 4th plus 5 times x to the 4th minus 3 equal to 0. So setting each of these equal to 0, I get x to the 4th plus 5 equal to 0, which means x to the 4th equals -5, and x to an even power can't equal a negative number. Or alternatively, x equal to the 4th root of -5. We can't take an even root of a negative number. That's not real. Over here, on the other hand, we will get something that's real. X to the 4th minus 3 equals 0. X to the 4th equals +3. X is equal to plus or minus the 4th root of 3. Right? Because whether it's positive or negative, if you raise it to the 4th power, it's going to end up being positive. So we get two solutions here. Well, let's do this one as well. Unfortunately, unlike the previous one, where there were numbers that multiplied to -15 and add to +2, it's not the case here. There's no way to multiply to +3 and have those numbers add up to +5. The only way to multiply to +3 really is 1 and 3, or -1 and -3, and those numbers don't add up to 5. So that means we're going to have to use the quadratic formula. So I would do a u sub here. I'm going to let u equal x squared. I'm going to say that u squared is x squared squared, which is x to the 4th. And say that this is u squared plus 5u plus 3 equals 0. And now when I solve this, I'm actually solving for u. So using the quadratic formula, u is going to equal -b, so -5, plus or minus the square root of b squared, so 5 squared, minus 4 times a, which is 1, times c, which is 3, all over 2 times a, which is 2 times 1, which is just 2. Simplifying, we get -5 plus or minus the square root of 25 minus 12 all over 2. And then we get u equal to -5 plus or minus the square root of 13 all over 2. So we have two possible values for u, but then we still have to go find x. So one value is u equal to -5 plus root 13 over 2, which is then going to lead us to saying that x squared is equal to -5 plus the square root of 13 all over 2. This is interesting. I think I picked an example that has no solutions. Sorry about that. Sometimes that happens. So the problem here is that this doesn't have any solutions because -5 plus root 13 is a negative number. Root 13 is less than 4. -5 plus a number smaller than 4 is negative. So if I try to take the square root of both sides, I'm going to get no solution. So x equals the plus or minus the square root of -5 plus root 13 over 2. That's the square root of a negative number. And the same is true for the other number. Sorry about that. That was unintended. I meant for one of them to work and one of them not to, but I must have messed up a number when I did it. So the other one's going to be u equal to -5 minus root 13 all over 2. And if you set x squared equal to that, again, I think this one even more obviously is clearly a negative number, so no solution. So sometimes equations have no real solutions. Bummer. The point of this really, though, was to see that if you have something quadratic like this, sometimes you have to do the quadratic U substitution and then also use the quadratic formula. Sorry, it didn't work out. I can give you another example later if you want. It does. More solving equations by factoring. So, something not to do here. It's really, really not a good idea to divide both sides by x squared. Here's what happens if we do that. If we divide both sides by x squared, x to the fourth divided by x squared, we subtract the powers and get x squared. 49x squared divided by x squared, we get 49. And then our solutions are x equal to plus or minus the square root of 9, which are plus or minus 7. And those are correct, but we missed out on x equal to 0 as a solution. So the safer way to solve equations with powers of x is to put all of the things on one side and set it equal to 0. I personally like to pick the side where x to the highest power is a positive coefficient. So I'm going to write this as x to the fourth minus 49x squared equal to 0. Then I'm going to factor out an x squared time and be left with an x squared minus 49 equal to 0. I can factor this further as x minus 7 times x plus 7. If I set each factor equal to 0, x squared equal to 0, the only solution is x equal to 0. X minus 7 equal to 0, the only solution is x equal to 7. And x plus 7 equal to 0, the only solution is x equal to negative 7. So, important to be careful there. I'm going to apply the same sort of thinking for this next one. So I'm going to bring everything probably to the left side, but this one's kind of weird, I will admit. So I'm going to have x plus 1 to the fourth minus x squared times x plus 1 squared equal to 0. I'm going to factor out an x plus 1 squared from both of these terms. So I factor out an x plus 1 squared. Here I'm still left with an x plus 1 squared, because x plus 1 squared times x plus 1 squared, you would add the powers and get x plus 1 to the fourth. Minus, here I'm just going to have an x squared, because x plus 1 times x squared is, x plus 1 squared times x squared is x plus 1 squared times x squared. And now we're going to simplify. We're going to say, I'm going to leave this x plus 1 squared out here. I'm going to multiply out the insides here. So x plus 1 squared is x squared plus 2x plus 1 minus x squared. I'm going to cancel the x squareds there and get x plus 1 squared times 2x plus 1 equal to 0. I'm going to set each factor equal to 0. So that's going to give me x plus 1 equal to 0, which gives me x equal to negative 1. I'm going to set 2x plus 1 equal to 0, get 2x equal to negative 1, get x equal to negative 1/2. Cool. So, similar idea here. I'm going to write these, kind of similar. But these are kind of just kind of a hodgepodge. Here, what I'm going to do is I'm going to write both as powers of x. I'm going to write this x to the 1/2 minus x to the 1/3, equal to x to the 1/3. I am going to bring the x to the 1/3 to the other side though, because the 1/2 power is the bigger power. So I'm going to write this as x to the 1/2 minus x to the 1/3 equal to 0. I'm going to factor out the smaller power from both things. Actually, I'm going to write the common denominator first. So I'm going to write this as x to the 3/6 minus x to the 2/6 equal to 0. I'm going to factor out an x to the 2/6 and left with an x to the 1/6 minus 1 equal to 0. So either x to the 1/3 is equal to 0, which means x is equal to 0, or x to the 1/6 minus 1 is equal to 0, which means x to the 1/6 is equal to 1. And if I take the 6th power of both sides, I get x equal to 1 to the 6th, which is just 1. So my two solutions, which we probably could have seen without doing all this work, are 0 and 1, because the square root of 0 is 0, and the cube root of 0 is 0, and the square root of 1 is 1, and the cube root of 1 is 1. Negative 1 is not an answer because the square root of negative 1 doesn't exist, and the cube root of negative 1 is negative 1. All right, a bit more to go. I know this video is kind of long. Sorry. Solving rational equations. So if we're solving a rational equation where we just have like numbers in the denominator, the easiest way to deal with this is to multiply both sides by the least common denominator, or actually any common denominator, which in this case I believe is 24. So multiply everything by 24. I'm going to get 24 times 1/3 is 8 times x plus 2. 24 times 1/4 is 6 times x equal to 24 times 1/6 is 4 times x minus 5. And 24 times 1/8 is 3. Now we're going to distribute out everything. So we're going to get 8x plus 16 plus 6x equal to 4x minus 20 plus 3. Combine like terms on each side. 8x plus 6x is 14x plus 16 equal to 4x minus 20 plus 3 is 4x minus 17. Combining the x's on the left, 14x minus 4x is 10x. Subtracting 16 on the left, negative 17 minus 16 is negative 33. So we get x equal to negative 33 over 10. I'm going to pause the video for just 1 second, and I'll be right back here. And that's my screen sharing that is paused. Sorry. Pausing the video is always annoying. Continuing on. So the same idea applies here, except now we have to be a little extra careful. We want to make sure we don't have any solutions that aren't actually solutions. So we have to point out that that should be a 25, not a 5 there. We don't want x to equal -5 or x to equal +5. Those would not be good solutions because they would end up making us divide by 0. But then the same kind of idea holds. If we look at this, we have 3x over x plus 5 equal to 2x plus 1 over x squared minus 25 does factor as x plus 5 times x minus 5 minus 1 over x minus 5. We really can just multiply both sides of this equation by the least common denominator, which is x plus 5 times x minus 5. Same deal over here. So the point of doing this is that we're going to cancel out the denominators. So you multiply x plus 5 times x minus 5 by 3x over x plus 5. The x plus 5's cancel, and you're left with x minus 5 times 3x. When you multiply this by that, the whole entire denominator cancels, and you're left with just 2x plus 1. Minus, when you multiply this by that, the x minus 5's cancel, and you get -1 times x plus 5. Multiply it out, we get 3x squared minus 15x equal to 2x plus 1 minus x minus 5. Bring everything to the left-hand side. We've got 3x squared minus 15x. I should have combined like terms here. 2x minus x is just x, so subtracting an x, you get minus 16x. And 1 minus 5 is -4, and adding 4 to both sides. I feel like this one came out nicer before. I guess not. And so then, unfortunately, I'd probably have to use the quadratic formula here. So my solution would be x equal to -16 plus or minus the square root of -16 squared, which is kind of gross. It's 256 minus 4 times 3 times 4 all over 2 times 3. Yeah, not my best work ever. This is going to be 16 plus or minus the square root of 4 times 3 times 4 is, let's see, 12 times 4 is 48. 56 minus 48 is 8, so it's the square root of 208. All divided by 6. 208 is 2 times 104, which 104 is 2 times 52. 52 is 2 times 26. 26 is 2 times 13. So we have the square root of 16, which is going to be 4. So that's going to be 16 plus or minus 4 root 13 all over 6. And then we could divide each thing by 2 and get 8 plus or minus 2 root 13 all over 3. Kind of a gross example. I don't love that solution. The next one's a little nicer. Almost there. So same idea holds here. I have x over x minus 3, 11x minus 15 over x minus 3 times x plus 3, and 2 over x plus 3. I'll point out that 3 and -3 are not valid answers, but then we're going to just multiply both sides by the common denominator, x minus 3 times x plus 3. So I'm going to have x over x minus 3 times x minus 3 times x plus 3 equal to 11x minus 15 over x minus 3 times x plus 3 times x minus 3 times x plus 3. In this way, I decided to multiply it, to write it as each thing multiplied by the common denominator, as instead of just writing parentheses around the entire right-hand side. It's the same either way. So here, those cancel, and you've got x times x plus 3. Here, these cancel, and you just get 11x minus 15. And here, those cancel, and you get 2 times x minus 3. Multiplying things out, we get x squared plus 3x equal to 11x minus 15 plus 2x minus 3. Bringing everything to the left-hand side, we have 11x plus 2x here, which is 13x. Subtracting 13x from 3x, you get minus 10x. Sorry, I didn't leave myself very much room here. And then finally, minus 15 minus, oh, that's a minus 6. Sorry about that. Ooh, be careful there. See, good to check your work. Minus 15 minus 6 is minus 21, so plus 21 equal to 0. And then that's going to factor as x minus 3 times x minus 7 equal to 0. So our solutions are x equal to 3 and x equal to 7. But wait, x equal to 3 is not a valid solution. So our only solution is x equal to 7. All right, this next one here, we're going to cross multiply. So I'm going to say I have 3x plus 1 times x plus 13 equal to x plus 5 times 4x plus 8. I'm going to multiply it out. You get 3x squared plus x plus 39x plus 13 equal to 4x squared plus 8x plus 20x plus 40. Bring everything to the right-hand side so that the x squared coefficient is positive. So 4x squared minus 3x squared is x squared. This is a 28x. This is a 40x. 28x minus 48x is minus 12x. And 40 minus 13 is 27. And that's equal to 0. And then this factors as x minus 9 times x minus 3. So we get x equal to 9 or x equal to 3. Interesting. Oh. My shoulder's a little sore from all this writing. It's a long video. Almost done though. Almost done. Okay. So this is almost the same as what we did before, except you don't get rid of the denominator. So if I want to simplify a rational expression, I have to just get the common denominator. So here I'm going to multiply this piece by x plus 3 over x plus 3. This piece doesn't have anything to add to it. And this piece I'm going to multiply 2 over x plus 3 by x minus 3 over x minus 3. I don't know why I put parentheses there, I just did. Multiplying it out, I get x squared plus 3x over x squared minus 9 plus 11x minus 15 over x squared minus 9 plus 2x minus 6 over x squared minus 9. And then I guess I can write equal signs here. I can combine all the terms in the numerator. I get x squared. You get 3x plus 11x plus 2x, which is 16x. And I get minus 15 minus 6, which is minus 21. I feel like I'm, no, I see what's happening here. It's totally fine. They're at the wrong thing here. Let me double check one thing. Oh, I did. That's fine. It's not wrong. It's just different. It should be similar to the previous one, but not the same. And the denominator is just x squared minus 9. So I know it looks a little terrible. Sorry about that, but that is our simplified expression. Is one fraction. Same idea here. If we factor this, we have 3 over x minus 5 times x plus 5 plus 4 over x times x minus 5 plus 2 over x times x plus 5. And we want to get a common denominator, so we're going to multiply this part by x over x, this part by x plus 5 over x plus 5, and this part by x minus 5 over x minus 5. The common denominator is going to be x times x minus 5 times x plus 5. And we don't have to multiply it out. The numerator is going to be 3x plus 4 times x plus 5 plus 2 times x minus 5, which is going to be 3x plus 4x plus 20 plus 2x minus 10 all over x times x minus 5 times x plus 5, which is then going to be 3x plus 4x plus 2x is 9x, and 20 minus 10 is plus 10 all over x times x minus 5 times x plus 5. Yeah, it's too much writing. You guys are like, yeah, you could stop. I know, I know. Okay, last page. Absolute value equations are pretty easy. The insides can just be plus or minus whatever that is. So here we get x equal to plus or minus 7. We're done. Here we get 3x plus 1 equal to plus or minus 8. 3x equals negative 1 plus or minus 8. X equals negative 1 plus or minus 8 divided by 3. We should actually write that as two answers. Negative 1 plus 8 is 7 over 3, and negative 1 minus 8 is negative 9 over 3, which is negative 3. Here, there aren't any solutions. An absolute value can't equal a negative number. So no solutions. We don't want to make the mistake of saying 2x minus 3 equals negative 4 and 2x minus 3 equals positive 4. We don't do that for an absolute value equal to a negative, because an absolute value always takes an input and gives a positive output. And finally, this one, we're going to write x over 3 minus 1/4 equals plus or minus 1/6. Then I would do the same thing we did for problem, I think it was 20, I think it was problem 20. I'm going to multiply both sides by the least common denominator, which is 12. So 12 times all this, 12 times this, 12 times x over 3 is 4x, 12 times 1/4 is 3, 12 times plus or minus 1/6 is plus or minus 2. So then 4x is equal to 3 plus or minus 2. X is equal to 3 plus or minus 2 over 4. So x is equal to 3 plus 2 over 4, or 3 minus 2 over 4. All right, I know that was kind of lengthy, but I'm glad you hung in there, and I'll see you on Monday.